Hello everyone, and in this video we're going to be looking at some more slightly complicated instances of factorization. Okay, now in this course so far we've only been expanding brackets where we've had, or rather factorizing expressions where we've had a number in front of the x squared that's been 1. So for example, in the last video we were factorizing expressions like x squared add 4x plus 3. And the thing here is that we had technically a 1 in front of the x squared. And what I'd like to do now is to show you a technique for factorizing quadratics with a non-linear coefficient of x squared. Now that's fancy math speak for a number in front of the x squared or the y squared or whatever the letter happens to be. So let me just show you how this works. And it's an algorithm. So this is 2y squared minus 5y plus 3. So this is question 2c. Now, there's a number of ways to factorize this. One way is by inspection. And with inspection, what you do is you just write down the brackets and you think to yourself, okay, well, there really are only so many potential combinations. And you just maybe a little bit of trial and error, you kind of pick the right combination. And factorizing by inspection is absolutely fine. And, you know, especially if you're strong with your number work, you might prefer to do it that way. Okay, but I'm just going to show you an algorithm that I like that always works for factorizing quadratics. Okay, and of course we could always reverse engineer them from the calculator as well, being as the calculator is allowed on all papers. So we've actually got a number of options available to us. So how does this method work then? So the way it works is you take the number that's in front of the squared and you times it by the last term. Okay, so you do the 2 times the 3. So that's going to be positive 6. And then once you've done that, you go back to the same question that you were asking yourself when we were in the previous lesson. So you say, I'm looking now for two numbers that times together to make 6, but add together to make minus 5, the minus term here. And you think about what those two numbers could be. So for example, if I was to have minus 2 and minus 3, let's consider that. Minus 2 times minus 3 does in fact make positive 6, and minus 2 take away 3 does in fact make minus 5. So this is the correct factorization. Okay, the correct factor pair that we're searching for. Now here's what's new and a little bit different about this technique. You split the middle term into this factor pair. So you replace minus 5y with minus 2 and minus 3. Now we'll look in more detail in another example just to show you that it doesn't matter which way you put these, because sometimes students get confused and think, oh, well, should I put the 3 there or the 2 there, or should I put the 2 there or the 3 there? The answer is it doesn't matter. I've put the 2 there just because it matches the 2 there, and I've put the 3 here because it matches this 3. So I know I've got a common factor of 2 here and a common factor of 3, but it still would have worked if I'd have put them the other way around as well. Okay, and I'll show you that in a moment. So you split the middle term into the factor pair that you've identified. Okay, now you drop these down and write them next to them. So 2y squared, and you drop down the plus 3. So now you've got 4 terms in a line. Okay, and then sometimes people put a little partition there. You now factorize these two and say, what's the highest factor that can come out of these two? Well, it's 2y. So 2y, open bracket, y minus 1, close bracket. You then factorize these two. What's the highest factor that can come out here? And that is, you could take out minus 3, which would leave you with y minus 1. So I've factorized that term and I've factorized that term. Now, you know that this technique is going correctly if it's the case that this bracket matches this bracket. If they match, then you know that we're all good. And then whatever's written in front of these two brackets forms the other bracket. So in other words, 2y minus 3 is the other bracket. 2y minus 3 is the other bracket. And that is the expression factorised. Okay. Now, a second ago I was saying it really doesn't matter. Let me just go over those steps again. It's an awful lot to take in there, isn't it? So let me just review those steps. So when we use this technique when we've got a non-linear coefficient of x or y squared. In this case, we've got a 2. So this technique is going to be applicable in this case. We do the a term in a quadratic. We have ax add b, ax squared add bx add c. So the a term gets times by the c term. So 2 times 3 is 6. So you write down your 6 and then you put a times there. So you say we're now looking for two numbers that times together to make 6, but add together to make -5, which has come from there. You consider the appropriate factor pair, and once you find it, this time you split the middle term into that factor pair, and it doesn't matter where you put them. You could have put the -3 there, it would have been fine, okay? But I just put them because it made they had common factors of 2 and common factors of 3. So then you factorize the first two. What's the highest factor that will come out? 2y, leaving behind y minus 1. You factorize the second two. Highest common factor is -3. That leaves me with y minus 1. Once you get to this stage, you know it's correct if these two brackets match each other. So this one and this one, if they match, we're good. It's all correct. And then the final bracket, the 2y minus 3, it's been formed by combining whatever's written in front of these two brackets. So 2y minus 3. So that is the other bracket. Okay, so that's how this technique works. Now, let's just consider, just to show you for interest, let's imagine I had chosen to split that term the other way. So I've got 2y squared minus 5y add 3. Let's say I've correctly identified that this is the correct factorization. But let's say for whatever reason, I chose to write -3y and -2y here. Let's see if the whole thing still works. Okay, I'm just writing down those terms the same as I did before. I'm going to now do the same as I did, factorize these two. Well, the biggest thing to come out of this one is y, going to leave me with 2y minus 3. The biggest thing that can come out of this one is a -1, but -1, and that would leave me with 2y minus 3. It looks correct because remember we said that if these brackets match, then you're on track. So that they match, so we're clearly on track. And remember we said that whatever's written in front is your other bracket. So y minus 1 must be the other bracket. And lo and behold, we found out we've got the same answer. It was formed in a slightly different way. So you really mustn't worry that if you're ever employing this technique, it really doesn't matter which way you choose to split them. Okay. Now have a look at some of the those questions there in question 2, and use this technique to have a go at factorizing them. It's certainly a useful technique. It's a good thing to know how to do.